My name is Joseph Richburg, Senior Data Architect at Penguin Random House. On today's Azure tutorials, we're going to discuss preventing SQL injection. Let's begin. Today's topic is SQL injection attacks. I really didn't think I'd be making a video about this. Being, however, cliche of the 21st century, I didn't think this problem was as prevalent as it seems to be. I'm beginning to see more and more articles written on SQL injection attacks. So, as a system architect, it is important that all the data we have is secure as we can possibly make it given the tools that we have. And using Azure SQL Server and Azure DW, I have the tools to make the data 100% resistant to a SQL injection attack. So let me show you what a basic SQL injection attack would look like. In other words, what the goal of this SQL attack is. So what we have up here is some C# code. I use C# in my Azure functions. And here we have what the application wants. So in this case, it's a SQL command. And what the application really wants is a count of the number of users in the system. So as you can see here in this example, let me get rid of this so you can highlight it. This statement is an actual SQL statement. When it goes to the database, it will actually run that command. So what SQL injection does is the hacker gets hold of the stream of data between the application and the backend. And in this case, with SQL injection, this code is being sent. So what the application is doing is the application is saying, here is the SQL command I want you to run, and give me back the information. And the problem with that is, let's say that the hacker does get a hold of the line and decides to do this. So what has now happened is rather than counting the number of people in the confidential table, you're getting all the information from the confidential table. That's it. That's the simplest explanation of SQL injection. I change the actual command because in this situation, the contract between the front end and the back end is you do whatever I ask you to do. So the back end says you're asking for everything from this table. Well, you have permission to see it because I needed to give you permission to do a count of it. I'll just do whatever you ask. So I'll send you everything. Now, there are some systems where you could say, okay, to prevent that, we are going to encrypt or mask the user-specific data in the columns. So you can see the data, but you won't be able to see any real information. So rather than a social security number, it's just a whole bunch of X's. Rather than a user name, it's just a whole bunch of gibberish. And that's a good way to start, to have the data at the database level encrypted or obfuscated in ways that make this harder. But there's an even simpler way. The simpler way is not to tell the database, this is what I want. The simpler way is to tell the database, here are my parameters. I need you to give me information from this call. So let me back up a bit. Think of it as a function call. So whenever you're writing APIs or you're writing any type of code, any developer, the developer is going to have a series of functions that they internally call. Some of these functions will be presented to the world publicly, where you can call them. And sometimes developers say, well, I want to hide these pieces of inner workings because if you play with them, you're going to mess up the system. Same concept with the database. You don't want to expose the database to anything. You want everyone to come through a door or a gate. And by passing them through this doorway, you can successively reduce the security risk. And I'll show you how. So here would be the bad command. And it would look something like this. Right. So up here, we have this. And it's basically the same thing, except I'm passing in this string. So let me go up a little bit and show you. What it's basically saying is when I get this information from the request, Now, in the case with the systems I design, all requests are posts. We don't do any gets, so nothing is displayed in the address line. A lot of times, older systems will use a get, and the get will have the SQL command inside of the URL, and that's the simplest way for SQL injection. I just go in there, I adjust it slightly, and if there's no backend security, it'll run the command. So the one thing we do is we always use posts. Now, again, even if we use posts, if we have a sophisticated hacker and they do get a hold of the SQL line that's being sent, then this is no better because it's still going to run this. And what you're basically saying is, hey, give me what I ask for, don't ask. You tell the database, you already set up the contract that whatever is passed through this function or through this call is what I want. Do not question me. So the database goes, oh, you want everything? Here you go. And that's based upon the user ID that you're connected to, right? So that's another piece of security. You want to take the user ID and limit it, and I will show you how. So remember, think of these as successively smaller doors or filters to prevent these types of attacks. So we're still no better off rather than actually sending this. In this case, it's just a variable. Okay. So you're thinking, well, what's the first line of defense? So the first line of defense is what is called a stored procedure. And think of a stored procedure in SQL Server. Looks just like this. Here's a stored procedure. It's exactly as it sounds, a procedure. Some programming languages still call, there's function or procedure, same concept. In this case, what happens is parameters are passed, evaluated, and result sets are provided. Same as a function call in any application. You pass in some set of parameters, it does some work, and returns some results. And in this case, you directly control the result set, meaning the columns themselves, as well as the data within those columns. Now, the easiest way to think of procedures when relating to an application is it's an API call between the front end and the database. Just like when you develop a library or you develop an API for use, you say, I have certain functions that are private that help me manage and manipulate data, and I have certain functions which are public that the either application or if it's a library, the end developer gets to use. The reason you have private in libraries is you have inner workings. You develop this library over months or years, and you're like, there's some inner workings that the developers don't need to know about. I'm going to make their life easier. They pass me a bunch of parameters. I do some dirty work, and then I send it back. Same thing with the procedure. You're going to pass in specific data requests, and you're going to get back specific data values. So this is another restriction, another filter. So how does that work? So here's the malicious code that the hacker wants to inject. So it's selected. So let's put it up here. So when the front end, which was hacked, the let's not say the front end, the front end or the URL was hacked, that's what they pass in. So the first thing SQL Server is going to do is say, does the value being passed match the parameter data type, which is, am I less than or equal to 256 characters? Yeah, I fit that. Don't worry about this. This is just another parameter. Again, you can have many, many, many parameters. It says, okay, now I'm going to look at my code and see how this parameter is going to be used. So as you can see here, there's a specific number of columns that can be displayed. You can't change that. There is no command you could send to this stored procedure that will change those columns. Nothing. Same for here. This is a fixed list. Now, let's apply the filter. So what I say is the owner must equal whatever you're passing in. There is no owner with this statement. It won't happen. So what does SQL do? SQL says, oh, let me do this. Your result set is empty because nothing matches. And then down here, same thing. What's your result set? It's empty. Try as they might, there is nothing that they can put in here. No escape characters, nothing that will work because all you're doing is providing a match. You're simply saying where the owner equals this. Owner's never going to be a select, a delete, an insert, a truncate, a drop. It's never, because those are commands that have to be executed. And what I'm saying is no matter what you pass me, it's only ever a conditional statement. It's only ever a compare. Now let's take a step back for a bit. There is a command in SQL Server that enables you to run dynamic SQL. And it's a stored procedure itself, funny enough, called sp execute SQL. And it takes a string. So in this case, we're going to put the string upn. Actually look like this. So what that does is that says, I want to run dynamically anything that I put in there. Oops, and I want to put this in. So if I did this, and let's say we didn't do this because, we're using stored procedures, but the front end is still telling us what they want and how they want it. What you've just done is you've just given the hacker that information. So you've bypassed everything. What you've basically said is all this procedure is a container to run SQL, which is no better than just running the SQL right from the front end. So with rare exception, do you ever want to use sp execute SQL in a stored procedure that will be providing data to the outside world? So throw that away. Now, permissions. So hacker somehow gets the user ID and password that the front end uses to connect and call to the back end. So now we have a situation where the hacker directly connects to SQL Server and they want to then run code by themselves. Well, the way to stop that is by using this specific option within a stored procedure. So what you do is for a specific set of APIs on the back end, you create a user ID and password, credentials that you give to the front end. And those credentials have only the ability to execute a specific set of stored procedures, the ones you tell it. So let's say you have 10 stored procedures that this API exposes to the front end. You narrow down the permissions so that that user only can execute the stored procedure, which means if you get into the system, you still don't have access to do this select, even if you knew what that was. If somehow you've insider information or you gleaned, hey, I want to somehow change this or I want to get specific information from these tables, you can't do it. You try to run this by hand, like you just do something like that, it'll fail. You don't have permission. Not only will you not have permission, the way SQL Server works is you won't even see it. So you don't even see the tables. You won't even see the stored procedures. You would see nothing when you logged in. You have to know it. So you're blind. So one, you would have to know the names of the tables because SQL Server wouldn't show you because the ID doesn't have access to see the structure, doesn't have access to select from the structure. It only has access to execute. And what this says is if a person has permission to run this procedure, then provide them with the permission the owner has, right? So the owner would be the DBO. And as a DBO or a DBA or database owner, I have permission over all of my tables. So it says, oh, you're allowed to run this procedure? Okay, then that means I'm allowed to show you this data, but only through this container. It's a proxy. So that would be like going to a bank vault and saying, presenting your ID, and the person checks the ID and says, according to this, you're allowed to see this specific bank box. They lead you into the room, they take the box out, they open it up. Now, there are many other boxes there. All you see are numbers. In this case, they wouldn't even take you in the room. They would take you to a private room, they would come in with your box. You don't even get to go to the vault. You can't even see whether they have one box or 1,000 boxes. You don't even know the name or number your box is. You just know that this box in this bank is provided to you based upon your credentials. So that locks them out completely. So if you follow the practices of always using stored procedure, always using actually coded SQL and not SQL provided by the front end, restrict permissions to only run stored procedures, and then use this to get around needing to grant permissions, your database becomes secure from SQL injection. If you thought the content was informative, subscribe to the channel so you're notified of any new content. Hit a like if you thought this specific video was something you could use. And as always, leave comments below if there's a topic you'd like me to go over for the next Azure tutorial.